Hi class, Mrs. McBride here. I guess I never expected that I was going to have to be teaching you online, but this is pretty crazy. Today I want to do page 21 in your Waves note packet, which is talking about converging lenses, which we only really had a chance to touch on in class for a little bit the other day. I want to start every video out with a little joke, so here's today's joke. What is fast, loud, and crunchy? A rocket chip. Just a little humor for today. Okay, so what's the difference between lenses and mirrors? Well, the light travels through lenses just like we saw in the lenses lab. The nice thing is that there are some definite similarities between lenses and mirrors, but there are some definite differences. Okay, so the first thing I want you to do is hopefully you'll have a ruler or a straight edge at home, and we don't need any calculator for today. So we're going to start by doing the rules for converging lenses. Okay, so for me, the first rule, hopefully you remember, is, I'm sure you're saying it out loud as we go here at home, that you're going to go parallel, in this case lens, and then focal point. And then I'm sure you're saying, hey, I know the other rule is focal point, lens, parallel. Okay, and do you see this number 3 here? Well, that's my favorite one because it's the easiest one here, and that one says straight through. Okay, now you know that we've only been using 2 of these so far, so sometimes I cheat and I don't do this middle one, but it's up to you. So you'll see that when I do this, I usually do the first one and the third one, and if needed, I'll do the second one. Now, what's different? Well, the difference is what is real and what is virtual. Okay, so when we were talking about images with mirrors, they were real if the object and image were on the same side. Now, just to make things complicated, it's the exact opposite here. So a real image means that the object and image are on opposite sides. Okay, which means that a virtual image means that the object and image are on the same side. Okay? And if anytime you need to stop this and sort of regroup here or play it again, please do so. Now, the first thing I want to do is I'm going to draw kind of a straight line down through the center of all of my lenses. These lenses are called converging, which means that light is going to come together as it goes through the lens. Okay, they're going to converge. You also notice that based on the shape, you should be saying to yourself, hey, look, these are double convex. Okay, so same thing. So take your ruler, and you should be doing this along with me as well. And we're gonna go parallel and through the focal point. Since this is called a converging lens, it is going to come together on this side through the focal point on the opposite side. Ready? So I'm gonna line up this spot here, and it's gonna come through the focal point. Here I am, through the focal point, okay? The second ray, we're gonna skip. Again, if you wanna be a super nerdy overachiever, go for it. But we're going to be semi-lazy physics students here. And we're gonna go right to the last one, which is straight through. So I'm gonna line up my ruler here with the top of the object and also straight through the center, okay? You see how I'm able to have these two meet here? Okay, again, straight through I always like to do because it's super easy, okay? Now I'm gonna locate my image, and for me, my image is sort of here. Hopefully your image is very similar, okay? And then you're asking yourself, okay, is this image real or virtual? And hopefully you're saying, well, it is real because the object and the image are on opposite sides. Then you're asking yourself, larger, smaller, same. For me, this is kind of hard to tell. For me, mine looks about the same, but again, it really depends on what yours looks like, okay? And you're asking yourself, is this upright or inverted? And I'm sure I hear you all saying at home that this is inverted, all right? Piece of cake, so sort of the same, but sort of different. All right. You're right. We do get to do 3 more. Yes! I know, I'm excited too. All right, so same thing here. First thing we're going is parallel, and then we're converging or coming together by going through the focal point over on this side. Woohoo! Okay, and then we are going straight through the center. Wow, oh, I did not draw my line long enough here. Hopefully you guys did. Okay, I got all the way over here. Hopefully you guys got something similar, and look at this image here. This is crazy. Okay, is this real or virtual? Again, real, because the object and the image are on opposite sides, so it's real. Is it larger, same, or smaller? Mine came out much larger, and it's also inverted because it's pointing down, okay? My cats are starting to have a brawl here if you hear any hissing in the background. All right, feel free at any point if you want to just like stop this video and try this on your own and come back and check with me, you certainly can. Or if you want to go along with me, we're still going parallel, and then we're going through the focal point. Okay. And then for our second ray, we're going straight through the center. Okay, what do you think's going on with something that looks like this, right? These two look pretty darn parallel. So any thoughts? I hear you all the way from Greece saying perhaps there is no image. And there's no image because it's not like we need to the other side. These two are parallel, so they're never going to meet. So there is actually no image. So when we put an object at the focal point of the lens, we should find that there's no image. And if we were in class, I would show you that this is when we would see that like sort of blurry, fuzzy image, okay? All right, and last but not least, see if you can guess. What happens when we have an object that's inside the focal point? Hopefully you're saying whenever we've seen this in the past, we've had this virtual image. Okay, so let's see what happens here. We're gonna do the same thing here. So we're gonna go parallel, and then we're going through this focal point. All right, all right. And then we're gonna go straight through the center here. Okay, what do you think? Well, I see 2 rays. They don't connect on this side, but they're also not parallel. So hopefully at home you are making the ch-ch-ch-ch sound, and we're going to ch-ch-ch back to the other side. Here I am. I wonder if your families are gonna think you're weird when they hear you ch-ch-ch away at home. Ch-ch-ch-ch-ch-ch-ch. Okay. I've just ch-ch-ch-ch-ed, and I found that my image, if I could draw a straight line, that would be helpful. It looks like this, okay? Now we're asking ourselves, real or virtual? In this case, virtual, because they're on the same sides. They're both on the left-hand side, okay? Is this larger, same, or smaller? This one is larger, and upright or inverted. This one is upright, okay. So please tune in to my next video. I just want to make sure that none of the videos are too long, and they will upload to YouTube, okay? Which is going to be the exciting topic of diverging lenses. All right, so tune in, and I will talk to you in a bit. Bye-bye.